Hi Danielle, this is Don. I'm looking over your revision to the assignment 7A1, and it seems, just as you said in your email, you're having a problem with the constraints. I want to show you an example of how to set up that first problem about the grades, and the same procedure you can use for the other problems. The key is to really read the word problem and then to parse out, separate out the constraints. And you did that pretty well. I copied this off of yours. You said that the participation grade can be no more than 15% of the total. The midterm must count at least twice as much as the individual assessment. Final grade must be at least 3 times as much as the individual assessment. Each of the 4 components must count for at least 10% of the course grade, and the weights of all 4 must equal 1 and of course be non-negative. Well, let's look and see how you could set that up. And this is one of your classmates, and I just want to concentrate on how this person set up the model, and that's key to everything we do in this course, is to come up with a logical, simple model of the problem. And what this person did there was to list the assignments and the total grade. The grade that this person that you were given on the various components: 86%, 94%, 93%, 85%. And the question is to come up with weights that we multiply times these grades to give us the best total grade. And I'm going to click, I think, if I click there, double click there, and you can see how this model is set up, that this total is equal to each of these grades times its weight. That's just what that is saying there. Okay, now let's look at how to set up the constraints one way. And a way to think about them: constraints generally have a minimum value and a maximum value. And so this person said, well, for my midterm, it has to be 2 times the individual assignment. And that was what you had over here. The midterm must count twice the individual assessment. So 2 times the individual assessment. The final has to be 3 times the individual assessment. But on both those two, there's no maximum stated. It can be theoretically 100% of the final grade. Could be either one of these two. We get to the individual assignment, and the only constraint on it is that it must be at least 10% of the grade. So that's what this person had there, that the individual assignment was at least 10%. Participation also has to be at least 10%, but it can be no more than 15%. And that's out of what you said there. So we've got minimum of 10%, max of 15%. And then the total is 1 under both cases. Now, why did this person say that the only minimum constraint was 2 times the individual? Why didn't that person say that there should also be a constraint of 1/10 of 10%? Well, if you think about it, if the midterm is twice the individual, and the individual has to be at least 10%, then you've satisfied that 10% constraint for the midterm. Same thing for the final. If the final is 3 times the individual, and the individual has to be at least 10%, then that means the final has to be at least 3 times that 10%. So you don't need to put the 1/10 or the 10% constraint on these two. So that's one way to think about these constraints. Now let's look down here in the actual solver model, and it's set up the same way. This person, of course, remember the first part of the problem was just to guess at these weights, and this person was pretty savvy and guessed the optimum weights. But down here, we've got the same model. Total is equal to the sum product, if you want to use that instead of this long equation. And let's look at solver then and see how this person put that in. Data, solver, and here's our solver. And you can see that C21, which is our total grade, which is the weighted grade, remember, each of these, we want to maximize that by changing the cells D17 to D20. That's the weights, which is what we want to change. And then we can look at the constraints that we put in. D17, which is the midterm weight, has got to be greater than E17. What's E17? E17 is this minimum constraint again, 0.2, because if you think about it, if the individual assessment has to be 0.1 and the midterm is going to be twice that, then the minimum for the midterm is 0.2. Likewise, the minimum for the final is 0.3 because it's got to be 3 times the individual. So let's see. D18, which is the final, has got to be equal to E18, greater than or equal to that 0.3. D19, individual assessment, has got to be, the only constraint on it was a minimum greater than 10%, and that's what he's got there, greater than E19. Participation, though, has a max of 15% and a min of 20, so there should be 2 constraints there. D20 is less than or equal to F20, which is the maximum of 15%, and greater than or equal to E20, which is the minimum of 10%. And then the last constraint is D21, which is the total. It's got to be equal to 1. It can't be more than or less than, it's got to be equal to 1. So those are constraints. We've got the check off there of the unconstrained non-variables to be non-negative, and we want the simplex because this is linear programming. And that's all there is. It's very straightforward, and again, the fewer constraints you have in here, the more likely you are to get the actual optimum score. And that's what you get. If I click solve here, we'll let it solve. We've got a solution, and of course nothing changed. We've got the 91.4% for the total grade, which is the optimum grade, with these mixtures of the midterm at 0.2, the final at 0.6, that's when it really had to be big there, and individual and participation both at the minimum values of 10%. Danielle, I hope this helps, and I'm not going to go through those other problems because they have similar problems in your setup. Key again is to take some time, parse the word problem, looking for the constraints, looking for the objective function, and then set up a simple model, just as concise and as straightforward as you can. And again, I like this way of coming up with a table and showing the minimum and maximum values for each of your constraints. And everything you need for Solver is contained in this little bitty area. So you can do this. Hang in there.